Hello. Yes, we welcome you back to PSSB with me, Richard here. Now we are looking at this question. It says that briefly explain each of the following intermolecular forces and give examples in which they exist. Okay, the first one is ion dipole forces. Okay, now to analyze this one, when you say ion, it means that one of the compound is ionic. Dipole means that the other compound is polar. So this interaction, what is it? So this is the type of intermolecular forces which is existing between an ionic compound and a polar compound. Yeah, that is that. And the example is sodium chloride dissolved in water. Okay. Yeah, in this case, we can look at the situation. If you look at sodium ion, it's positive. So you have to know that the water, which we know, this is how it looks like. This side is partially negative, and this side is partially positive. So because of this one being positive, the oxygen will come here and the hydrogen will go there. Because oxygen is negative, it will come to the positive. Okay. Meanwhile, because it's sodium chloride, the chloride will come here. Yeah. So this interaction is what we call ion dipole. Yeah, then we come to this one, ion-induced dipole forces. Okay, you have to know that when you hear the ion, it means that we are having an ionic compound in play. And then induced dipole, it means that this compound is not having permanent dipole. So it's not polar, it's non-polar. So that is it. What is it? This is the type of intermolecular forces existing between ion and non-polar molecule. Yeah, that is it. It exists between an ion and a non-polar molecule. The example we have is found inside red blood cells. Globin, responsible for carrying is hemoglobin in red blood cells. So what we have to know is that inside hemoglobin there is a ferric atom, iron 3. So iron 3 induces oxygen because this hemoglobin is responsible for carrying oxygen. It's a pigment for carrying oxygen. So what happens is that oxygen is like this one. So it comes near the positive 3 ion, which you call ferric ion, and this ion induces this one. So whereby this side, it partially becomes negative, the side near the ion, and this side partially becomes positive, but they are not permanent, so we don't write them there because they come and go. So that is it. You have to know that oxygen is non-polar. That's the one, and the ion is this one, the positive ion. Yeah, then we come to this one, dipole forces. What are they? So these intermolecular forces are existing between one polar molecule and another polar molecule, or one dipole molecule and another dipole molecule. Yeah, that is it. And the example, we can look at this, hydrogen chloride. Okay, you have to remember that chlorine is more electronegative than hydrogen, so it tends to pull bonded electrons to itself, making it partially negative. Meanwhile, hydrogen becomes partially positive. So because this one is partially negative, the next link will be the hydrogen, which is partially positive. Remember that action is between unlike charges. So that is it. So this is what we see. So this link here is what we call dipole. And this bond exists between two molecules which are permanently polar, or which dipolar. Yeah, then we come to this one, induced dipole, induced dipole. Now, I want you to remind you that every time you hear the word induced, it means that molecule does not have dipole. Induced means that it is forced by some circumstances to attain dipoles, which do not even last longer. It eventually reverts back to not having dipole. So induced dipole means that we are having interaction between two molecules, both of which are non-polar. Yeah. The example is like the forces which are existing between two methane molecules. Yeah. So this forces are induced dipole. Why? Because both molecules are non-polar. Okay. Then we come to this one, dipole, induced dipole. You have to know that dipole implies the molecule is polar. Okay, induced dipole means that the molecule is non-polar. So the interaction here is between two molecules, one polar and another one is non-polar. Yeah, the example is the interaction between trichloromethane and tetrachloromethane. Yes, you have to know that this one is non-polar, while this one is polar. Yeah, both are organic in nature, so there's a tendency of them to react. Yeah, but you have to know that it's between a polar. The polarity of this one is caused by having distribution of atoms around carbon, which are not of the same. So that one makes the molecule to be non-symmetrical and so becomes polar. These four chlorine are the same, so the molecule is symmetrical, so it is non-polar. Yeah, then we come to hydrogen bond. Actually, hydrogen bond is a dipole, but so strong to another level. What is it? Is the type of intermolecular force between hydrogen. Okay, but this hydrogen must be special. Hydrogen must be attached to a very electronegative atom, and another electronegative atom. Yes. Okay. The bond is between the hydrogen and another electronegative atom. But this hydrogen must be attached to an electronegative atom. So the example is between water molecules. Okay, water is special. This is what we know about water. That we have this one as its shape. There are two lone pairs here which are pushing it into this way. And these hydrogens are positive. Meanwhile, oxygen is more electronegative compared to hydrogen, so it pulls electron towards itself and becomes negative. But you have to know that because this one is positive, it will take at a link with the oxygen of another water molecule in this manner. You have to know that this oxygen is negative. Remember, the link is between oppositely charged particles. So the hydrogen will come here with its partially positive and also have here with its partially positive. So this intermolecular forces between this hydrogen and oxygen is hydrogen bond. Yes. So we come to this question. It says that consider the two sets of molecules below linked together. We have the first set A and B. Okay. Then the question says that identify which of the bonds above are intermolecular forces and state the type of each. The first one is X. X is intermolecular force. Okay. And what is the type? It is hydrogen bond. We know that those intermolecular forces existing between water molecules are hydrogen bonds. Okay, which other forces here are intermolecular forces? M. M is also another type of intermolecular forces. And what is it? M is between methane and methane. Methane is a nonpolar molecule. So what are the forces between two nonpolar molecules? Okay, the force is induced dipole, induced dipole. Okay. Sometimes we call it London forces. Yeah, then comes this one. It says, identify which of the above forces or bonds are interatomic forces or intramolecular. Okay, the first one is Y. Y is between atoms, so it is intraatomic. It's within a molecule, so it's intramolecular. But what's its nature? It is covalent bond. Then we go to N. N is also interatomic or intramolecular, and the nature is the same. What is it? Covalent bond. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. I would like to urge you to subscribe, to comment, to like, to share, and also to remind you that this channel, Physical Sciences Silver Bullet, handles Physical Sciences grade 12, 11, and 10, and Natural Sciences grade 8 and 9. We recommend that when you're using our channel, please use our playlist, well simplified for you. For grade 8, just look for Natural Sciences grade 8 or Natural Sciences grade 9. For grade 11 and 10, look for Physical Sciences grade 11 and Physical Sciences grade 10. As for grade 12, each chapter is presented independently. So just look for the chapter of your choice and you'll have all the material you need for that topic. With that, I would like to say thank you, stay blessed, see you next time, bye-bye.